Lesson 211, Analyzing Quadratic Functions in Standard Form. All the vocabulary. You'll see a lot of vocabulary over and over again. All right, example 1. Graph the parabola using its vertex, line of symmetry, Y-intercept, and strategic points. So you notice this 5-step process here. We're going to use this every time we have a parabola in standard form. And we're going to want to have 5 points to draw our parabola just to keep it fairly accurate. Okay, so remember, all these 5 steps over and over again. So standard form is going to be this form here where you see ax squared plus bx plus c. Anytime you have that, we have a parabola in standard form. So going to step 1. Up or down. So there's a parabola, open up or down. So parabolas happen in shapes in U-shapes. So that would be a parabola that opens up, and this would be a parabola that opens downward. Now to determine whether it opens downward, we got to look at this a value here in front of the x squared, right? So it's the coefficient in front of x squared. If it's positive, right? So if we're looking here on the left side, if it's positive, it's going to open upward like this, or if it's negative, it's going to open downward, right? That kind of gives us an idea of how our parabola should look. So looking at this here, our a is -1. It's negative, which means our parabola will be opening downward. So when we go and we plot our points, and if it doesn't give us a U-shape, then we know we did something wrong. Okay, so step 1 is done. We know our parabola is going to open downward. Now step 2, the vertex. So the vertex is going to be the middle of our parabola. The first thing we have to do, we have to find the x value of the vertex. Right? So the vertex is going to be an xy coordinate. Right? And we're going to plot it after we find it. Now, to find the x value of the vertex, we have to use -b divided by 2a. Right? That's that formula I just got from here. Now, plugging it in. Right? So remember, we have our, just to make it a little more clear, we have a, we have b, and we have c. A is -1. B is -2, and C is 3. Okay, now plugging it in to find the vertex. We're going to have the negative from the formula, and we're going to plug in B, and B happens to be -2. We're going to divide it by 2 times A, and A is -1. Simplifying this out, negative times a negative is a positive. That's 2 divided by -2, which is -1. So now our vertex, the x value of our vertex here is -1. Now to find the y value of the vertex, we have to take this -1 and plug it in to the equation. That's what that here means, that function of -b divided by 2a. That just means that we're plugging in whatever we got for -b divided by 2a into the problem, into the equation, and we're going to solve it. So we got that it's -1, so -1 is the number we're going to be plugging in. So we have, right, we're plugging it into here. So we have negative times, instead of writing x, we're going to plug in -1 squared minus 2 times, and again, instead of x, we're plugging in -1 plus 3. And now we simplify, right? And you got to remember your order of operations. Inside parentheses first, there's nothing to simplify inside parentheses, then exponents. So we're going to do this here first. -1 squared is a +1. And now +1 times that negative on the outside gives us a -1 again. -2 times -1, that's a negative times a negative. That gives us a +2. And then that plus 3 on the outside, and we just simplify. Negative 1 plus 2 is 1, plus 3 is 4. So our vertex is negative 1, and the y value is 4. Now I'm going to go ahead and erase this so we have room, but we do need to plug that negative 1, 4 in. So I'm going to go ahead and, let's see, I'll plug it in with blue. So we're going to go to negative 1 and then up 4. 1, 2, 3, 4. And that's where our vertex is. Now, going on to number 3. Draw the line of symmetry. The line of symmetry will always go straight down through the vertex. So if that's our vertex, our line of symmetry is straight down through the vertex. That's going to be that line that cuts our parabola exactly in half. Okay, next step, we're going to find the y-intercept. So now we're going to go on to number 4 here. Find the y-intercept, and to find the y-intercept, we plug in 0 for x. Okay, and that's always going to be the case. Anytime x is 0, our y-intercept, it gives us our y-intercept. So for y-intercept, we're going to plug in 0. And again, we're plugging it into this here, where I boxed it in purple, the equation. So we have negative 0 squared minus 2 times 0 plus 3. Now simplifying, all this here is going to be 0. 2 times 0 is 0, and then plus 3 on the outside. So we plugged in, so for y-intercept, we plugged in 0, and we got 3. That's our y-intercept. And we're going to want to plot that on the graph at 0, 3, right there. Now, the reflection rule. Because remember that parabolas are perfect U-shapes that are cut in half, and that axis of symmetry cuts it in half. So now, if this point here is just 1 unit away from the axis of symmetry, that means 1 unit on the other side, we're going to have another point. So that gives us a free point there. So now we have a total of 3 points. And now our last step, strategic points. So we want to choose an x value that's fairly close or within the parabola, the data that we already have in here. And it has to be an x value that you're going to choose to plug in. So if I'm looking, I already have a value for negative 2, I have a value for negative 1, I have a value for 0, so we can't use those. I'm going to pick the easiest one that I can think of. I can choose to do negative 3, or I can choose to do 1. I'm going to choose to plug in 1 for my strategic point. So if I plug in 1 here, it'll give me the y value of the coordinate of where this parabola should be. So I'm going to plug in 1. So we have negative times, instead of x, I'm going to put 1 squared minus 2 times 1 plus 3. See, 1 squared is 1 times that negative 1 on the outside gives me negative 1. Negative 2 times 1 is negative 2 plus 3. And that simplifies out to 0. Negative 1 minus 2 is negative 3 plus 3 is 0. So I know I plugged in, for my strategic point, I plugged in 1 and I got 0. And that's my other coordinate. So I go to 1, 0. And now that same rule again. This point is 2 spaces away from the axis of symmetry. So 2 spaces away from the axis of symmetry on the other side gives me my other dot that I missed, the other coordinate that I'm missing. Should be down here. And now I have enough data, right? I need my 5 points to go ahead and draw my parabola, and just try to draw it the best you can. I don't make these things perfect either. And that's what our parabola should look like. Okay, keep in mind, remember step 1, it opens downward, we got a downward facing parabola. Alright, example 2. Example. Okay, so it's another graphing of parabola question. So using its vertex, line of symmetry, y-intercept, and strategic points. Okay, first thing I'm going to do, which I think I should have done in the first example as well, is first make a little key of what A equals, B equals, and C equals. So my A here equals 1. My B is -6. And my C is 9. Okay, now, step 1. Does this parabola open up or down? Alright, example 2. First thing I'm going to do is I'm going to go ahead and make a key that labels my A, B, and C values. So my A is 1, my B is -6, and my C is 9. Okay, I probably should have done that too on the first problem. So step 1, does a parabola open up or down? Is A positive or negative? And if you look at A is a +1, so which means our parabola is going to be opening upward, which we have a U shape. Step 2, we got to find the vertex. And remember, the vertex is the XY coordinate. And to find the x value of the vertex, we use -b divided by 2a. Okay, plugging in what we know about b and a, we have the negative sign from the formula. B is -6 divided by 2 times a, which is 1. Simplifying that out, that's 6/3, which is 2. So I know the x value of my vertex is 2. Now to find the y value of the vertex, we have to take our x value and plug it back in. And we're going to plug it back into here. Right, so I know x is 2. I've got to plug 2 in. So that's 2 squared minus 6 times 2 plus 9. Simplifying that out, that's 4 minus 12 plus 9. 4 minus 12 is -8 plus 9 is a +1. So my vertex is at 2, 1. I'm going to go to my graph and plot that. So at 2, 1. That's my vertex right there. Step 3, we got to draw the line of symmetry. The line of symmetry, remember, always goes straight down the vertex there. And it's that line that cuts it in half, and it's your reflecting line. Okay. Step 4, find the y-intercept. And for y-intercept, you're always plugging in 0, so your x value is going to be 0. Now when we plug in 0, we get 0 squared minus 6 times 0 plus 9. So we have 0 plus 0 plus 9, which just gives us 9. So at 0, 9 is our y-intercept. 0, 9, y-intercept. And remember to reflect your point. If we're looking at this, that's 1, 2 away from the axis of symmetry, so 2 away on the other side is our free point. Right? And you want to take advantage of those free points. And step 5, our strategic point. So remember, you can't pick a value that already has a dot on it, but you want to pick it so it's close within your parabola. You don't want to pick something like -5 because that's going to be way off the graph. And you don't want to pick something like 10 because that's going to be way off the graph as well. But for me, I noticed that 1 doesn't have a value yet, so I'm going to choose 1 to plug in. I'm going to keep it easy for myself. So for my strategic point, I'm going to label it SP. I know I'm plugging in 1, comma, and I'm going to figure out what I get when I plug in 1. So we have 1 squared minus 6 times 1 plus 9. 1 squared is 1 minus 6 plus 9. That's -5 plus 9. That's 4. So at 1, 4 is my strategic point. So if I go to 1, 4, get my strategic point, and I get my free point that I can reflect. And we have our parabola there. A U shape, and to verify with step 1, we know that it opened upward and our parabola opens upward. Okay, let's go to example 3. Example 3. Okay, so graph the parabola using vertex, line of symmetry, Y-intercept, so same steps. And we have the same 5-step process for this one as well, except if you look at the problems that are given, let's make our key here, A, B, and C. So we know A equals 1, B equals -5, and now C, there's no value here, so we can assume it's just +0. So C is 0. Right, so we just put that 0 there just for a placeholder. So now we do our 5-step process. Step 1, does it open up or down? So we got to look at A. A is positive, so it opens upward, so we know we're going to have a U shape. Step 2, find the vertex. And again, the vertex is an XY coordinate. And to find the x value of the vertex, we have to use -b divided by 2a. So the negative from the formula, we have to bring that over first. B is -5. So negative times -5 divided by 2 times a, which is 2 times 1. That gives us 5/2, which is 2.5. Okay, don't get scared off because it's a decimal. It doesn't really make it much harder. So x is 2.5, comma, and now we got to find the y value of our vertex. And again, to find the y value, all we have to do is plug 2.5 in, and we're plugging it into here to see what we get. So we get 2.5 squared minus 5 times 2.5, and then plus 0 I'm not going to write because it's just going to be 0. So let's see, 2.5 squared gives us 6.25. -5 times 2.5 gives us -12.5. So now 6.25 minus 12.5 gives us -6.25. Okay, so our vertex is 2.5, -6.25. Okay, now plotting this might be a little difficult, but get as close as you can to it. It doesn't have to be perfect. So if we go to 2.5, 2.5 is here between 2 and 3, and down -6.25. -6.25 is 1/4, so about right there. That's going to be our vertex. Okay, now when we have our vertex, step 3, you draw your line of symmetry. Remember, your line of symmetry goes straight down through the vertex, and the vertex is between 2 and 3 at 2.5. Right there. Okay, now step 4, we had to find the y-intercept. And remember that you're plugging in 0, so it's going to be 0, comma, whatever we get. So it's going to be 0 squared minus 5 times 0, which is just 0 plus 0, which is 0. So our y-intercept is at 0, 0. It's at the origin. Right there. Okay. And remember to reflect. So this is 1, 2.5. So it's 2.5 away from the axis of symmetry. So we got to go 2.5 away on the other side. So from axis of symmetry to 3 is 0.5, 1, 2. So at 5, we're going to have another point right there. Okay, and last step, we got to find our strategic point. And for our strategic point, it looks like we could choose 1 again. Right, 1 doesn't have a value, so I'm going to choose 1. So I'm going to plug in 1 and I'm going to see what I get. So we have 1 squared minus 5 times 1. 1 squared is 1 minus 5, that's negative 4. So at 1 comma negative 4 is our other point. 1, negative 4 right there. And remember to reflect it, it's 1 and then half away, so 1.5 away. So from the axis of symmetry we go our half and then 1. So that's 1.5. Our point should be right there. Right there. And we have our parabola that opens upward. All right, example 4. Come on. No. There you go. Okay, example 4. We're given a little word problem here, but it's going to be the same exact way. And just try to draw it to the best of your abilities. So the flight of a rubber band follows this quadratic equation. H of x equals negative x squared plus 6x plus 7, where h of x represents the height of the rubber band in inches. So just a quick thing, h of x here, that just means y. And remember that the y-axis goes up and down. So the height, the up and down, represents the height of the rubber band in inches, and x is the horizontal distance the rubber band travels in inches. So each one of these is going to be considered 1 inch on the x-axis. So graph the quadratic equation and reveal the following. What was the greatest height of the rubber band and how far did it travel horizontally? Okay, so now let's start graphing this first. That's the first thing that we have to do. So let's get a nice graph going. Oh, sorry. Yeah. Let's get our data first. That makes more sense. Okay, so step 1. When we graph this, now does this open upward or downward? Remember, we got to look at that a value here, the number in front of x squared. It happens to be negative 1, so we know our graph is going to open downward. We're going to have a parabola that opens this way. Right? Imagine you're taking a rubber band and shooting it in the air. Right? You shoot it, it goes up, and then it peaks and comes back down. Okay, next step, we got to find the vertex. And again, that vertex is an xy coordinate. It's xy coordinate, we just got to find it. So we use, to find the x value, we use negative b divided by 2a. All right, we have a, b, and we have c. A is negative 1, b is 6, c is 7. Okay. So plugging it in, negative, our b is 6, divided by 2 times negative 1, which is negative 6 divided by negative 2, which is a positive 3. So the x value of our vertex is 3. Now remember, to find the y value, we got to plug it back in. So we have negative times 3 squared plus 6 times 3 plus 7. So we do 3 squared first. 3 squared is 9 times that negative 1 on the outside. That's negative 9. Plus 6 times 3 is 18 plus 7. So negative 9 plus 18 gives us positive 9 plus 7. That's 16. So at 316, that's our vertex. I'm going to go ahead and write that here. I'm going to make a little key. So my vertex was 316 because there's a chance I'm going to end up erasing all this. So we can draw our graph. Okay, next step is our axis of symmetry. And remember, axis of symmetry is just that line that you draw down the vertex. So when we go to plot this, we can just go ahead and draw the axis of symmetry in. Step 4, our y-intercept. And remember, with y-intercept, you're plugging in 0. So if you plug in 0, we got to find out what we get. So we have negative 0 squared plus 6 times 0 plus 7. And by now, you guys should notice that that's going to cancel out to 0, that's going to cancel out to 0, and we just have 7 left over. So our y-intercept is at 0, 7. And I'm going to plot that in there. And step 5 was our strategic point. It's a little tricky picking the strategic point because we can't see on the graph where we have our values, but we know our vertex is at, so if we look at the x values, we know our vertex, which is the middle, is at 3. Our y-intercept we got at 0, so that means that the free point that we get is going to be over here at 6, right? Because 3 is the vertex and it's in the middle. So it looks like 1 is open for this one, so I'm going to go ahead and choose 1. Right, and we'll see it on the graph when we get there. So for strategic point, I'm going to plug in 1, and let's see what we get. So we have negative times 1 squared plus 6 times 1 plus 7. 1 squared is 1 times negative 1 is negative 1 plus 6 plus 7. Negative 1 plus 6 is 5 plus 7. That gives me 12. So my strategic point is at 1, comma 12. Okay, now we got to go ahead and graph this. And I'm gonna erase a lot of this, but you can always rewind it and refer back to it. And I'm gonna draw our C316. Okay. See, that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so my vertex I'm going to plot in first. It's at 316, so I'm going to go 3 up 16, and it's about right there. Make that a little bigger. 316 right there. And then remember how we said that the axis of symmetry runs straight down the vertex. That's our point of reflection there. And again, it's a little hard because we don't have a graph paper here, but it works the same. Now our y-intercept was at 0, 7, so 0, 1, 2, oops, not that one. 1, 2, 3, 4, 5, 6, 7. That's right there. Okay, now we got to reflect this. This is, let's see, 1, 2, 3 away. So 3 to the other side. 1, 2, 3 is our other strategic point. There's our free point, sorry. Okay, now strategic point is at 1, 12. So I started at 1, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's about right there. 1, 12. And now we got to reflect it. So it's 1, 2 over, 1, 2 over. About right there is our other free point. Now, drawing our parabola here. So now that we have our parabola, it's time to start answering these questions. So the question down below, let's see, I'm gonna erase this little stuff so it doesn't get in the way. What was the greatest height of the rubber band? So what is the highest that the rubber band reached? And if we look, the maximum that it reached was right there. Right, that's the highest point, that's our maximum point of this parabola. The highest point that it reached was 16 inches, right? So I believe this represents it. Yeah, so height of the rubber band in inches. So the highest it reached was 16 inches, which, I mean, it's not very accurate. And now, how far did the rubber band travel horizontally, right? Horizontally, we're talking about side to side. So if we look, we can assume that it was launched from right here. So we can say that that was the ground where we're standing, and we launched this rubber band, and it traveled all the way to here, right? I mean, it traveled going this way and then coming back down, but horizontally, it traveled 1, 2, 3, 4, 5, 6 inches across, and I believe we're assuming that this is where it hits the ground again, right? Because if it's launched from the ground and then hits the ground, and I'll have to double check that with the book. So how far did it travel horizontally? And we're talking about inches again, so it's 6 inches.